Simplifying radicals is going to be under kind of the same idea as what you do with simplifying fractions or simplifying expressions, but we're going to see that there's a whole new world when you open into simplifying radicals. So our target is it will simplify square roots of integers, simplify fractions with radicals, and rationalize fractions with radical denominators. So simplest form when you're dealing with radicals, it is simplified if the following things are true. First, the radical has no perfect square factors other than 1. When we're talking about the radicand, we're talking about what is underneath the radical symbol. So something like this, if I had 36a, that would not be simplified because I have a perfect square factor in there of 36. Second thing is the radicand contains no fractions, meaning there's not a fraction in this box. And thirdly, that no radicals appear in the denominator of the fraction. So here are some examples of simplified radicals. 3 times the square root of 5, 9 times the square root of x, or square root of 2 over 4. Those are all okay. Over here, these are the ones that are not okay. 3 times the square root of 12. This does not work because square root of 12 could be broken up to the square root of 4 times the square root of 3. The second one does not work because of the second criteria. The radicand cannot contain any fractions, so you'll see what we need to do there next. And then the third one is not simplified because I have a radical in the denominator. It's okay if the radical is on top. It is not okay if the radical is on bottom. So now we're going to look at different ways that we can simplify those radicals. So here are some of those tricks. The first one is the multiplication property of square roots. If I have the square root of ab, I can bust that up to a square root of a times the square root of b. So something like the square root of 48, this is not simplified because 48 has a perfect square factor of 16. Square root of 16 times the square root of 3 is the same thing. So what this allows me to do is take the square root of 16, which is 4, and then I can multiply that times the square root of 3, and that would be the simplified version. This kind of thing cannot be done in your calculator. If you punch in square root of 48, you're going to get some sort of decimal. You're going to get here we go. You're going to get the 6.928 and so forth, which does not work. However, if I put in 4 times the square root of 3, square root of 3, and multiply that times 4, I get that 6.928. I get the same thing, so they're equivalent, but my calculator will not simplify the radical for me, so it's important that you understand these tricks. So that's the first one. Pull out a perfect square factor. The second trick is removing those perfect square factors. So the same thing here. Square root of 160, I can bust that up into the square root of 16 times the square root of 10. So square root of 16 is 4. Times the square root of 10, which does not simplify, so my simplified form is 4 times the square root of 10. Another one is removing variable factors. So I also need to simplify down this square root of 80 here, but I can also simplify down the m to the 5th there. So let's start with the square root of 80. Square root of 80, I can break that down to, I could have the square root of 4. I know that's in there, and that would be times the square root of 20. Square root of 4 is 2. Then square root of 20 can be broken down into the square root of 4 times the square root of 5. The square root of 4 is 2, so that's going to be 2 times 2 times the square root of 5. So I have 4 times the square root of 5. Now let's deal with the variable factors. So m to the 5th. Let's bust that up. Think of it as square root of m squared times the square root of m squared times the square root of m. So what is the square root of m squared? That is m. Square root of m squared is m times the square root of m. M times m is m squared. So what happened here? I pulled out m squared because I could have also thought of that as square root of m to the 4th. the square root of m to the fourth is m squared, because m squared times m squared gives you m to the fourth. And when you have the 1/2 power there, that's the radical there. That's the square root. So if I were to divide 5 by 2, I get 2.5. So the 2 is here, and then the square root is the half of it. So I'm going to take my variable and this, and I'm going to piece those two together. So the simplified version is 4 times m squared times the square root of 5m. That is the simplified form. So you deal with the number part, and then you deal with the variable part. Okay. Another trick is if you multiply these two radical expressions. So I'm going to multiply 2 times 3 as 6, and then what's in the radical I can multiply together. So 7 times 14 is 98, and t times t to the third is t squared. So I have those together, and then I can look for perfect square factors. So 98, I can bust that up into the square root of 49 times the square root of 2. And then I'm going to have the square root of, and actually that should be t to the third. T to the third. So square root of 49 is 7. So I'm going to pull that out over here, and I'm going to have 6 times 7 times square root of 2, because that cannot be simplified. Now t to the third, think about what we did before. If I'm taking the square root of t to the third, that's like I'm dividing the exponent 3 in half, which is 1.5. So I'm going to have 1t that comes out, and then I'm going to take the square root of t for the half part of it. I'm going to take the t, and I'm going to bring it out here in front of the radicals. 6 times 7 is 42, so I'm going to have 42t times the square root of 2t. The 2 and the t come from where I took this square root and this square root, and I put both of those under the radicand. So the simplified version is 42t times the square root of 2t. Then we can also see some tricks of where we're dealing with division. So if I have the square root of 36 over 49, I can bust that up. Remember, this is one of the ways that it was not simplified, is if you had a fraction in the radicand. So I do the square root of the top and the square root of the bottom. Square root of 36 is 6, square root of 49 is 7, so 6 over 7 would be the simplified version. Rationalizing denominators is where it gets a little bit trickier. So to remove the radical in the denominator, remember the square root of 3 is okay, but square root of 7 is not. I'm going to multiply the top and the bottom by the same radical. So I'm wanting to get rid of square root of 7. Therefore, I'm going to multiply the top and the bottom both by square root of 7. This is a legal move, because when you are multiplying square root of 7 over square root of 7, that's really multiplying by the whole number 1, which is totally okay. So this is very similar to when you would rename fractions and adding and subtracting fractions. So when you multiply across, you're going to get square root of 3 times square root of 7, which is square root of 21. That cannot be simplified, over square root of 7 times square root of 7, which is square root of 49, which then would simplify to square root of 21 over 7. So when you rationalize that denominator, what's happening is it allows you to get rid of that radical symbol.